Hello guys, welcome to another day for networking labs. My name is Mbeko Johnson Bola, your lecturer in this series of networking labs. I will start by giving my excuse to some of you that have started following my channel for this lecture. I was so tied up with some work and some commitment that has made me not to post videos for the past month. But here we are, and today we are going to continue as we spoke about, because we are going to see the various different concepts in networking, and at the end of the day we'll put all these concepts together to build large and sophisticated network. So today we are looking at the concept of VLAN. So what is VLAN? Well, VLAN simply stands for virtual local area network. And there is one thing I want you guys to know here. VLAN is a concept that is mostly understood by network switches. Mostly by network switches. PCs do not understand the language of or the concept of VLAN. But IP phones do understand the concept of VLAN because they can speak the language of .1Q encapsulation. Okay? They can speak the language of .1Q encapsulation. So today we are going to look at VLAN. And why VLAN? What's so important about this concept of VLAN? Okay, so the number one important of VLAN is the fact that it can divide a single broadcast domain into a multiple broadcast domain. Remember, when you open your switch to configure, you have only one initial VLAN in it, which is VLAN 1. Well, we are going to look at that as we proceed with the lecture. And the second factor is that it is a layer 2 security. Okay, layer 2 security. Sorry for the writing. It's actually not a layer 3 security. It is actually not a layer 3 security. It is instead a layer 2 security. Okay, it offers layer 2 security. And the third option is the cost. Okay, VLAN reduces the cost in your network. So just imagine the fact that you are in an organization that has about let's say 6 different departments, and each of these departments has to contain at least 5 different PCs and a printer, and they have to be networked. So instead of you going to get 6 different switches to network the different departments, you can simply get a single switch, and then you put each and every department in their own various VLAN. Okay, so rather than buying 6 different switches, you get just one switch, and you put the ports. You put the ports, or you implement VLAN on the ports and divide the various network. Remember, we also said that VLAN offers layer 2 security. It offers layer 2 security in the sense that VLANs cannot communicate with each other. If there are a particular group of PC that belongs to a particular VLAN, those particular PCs can only communicate with the PCs within that VLAN. They cannot communicate with PC out of that VLAN. Let's say we have 5 PCs in VLAN 10, and we have also 5 PCs in VLAN 20. Those 5 PCs in VLAN 20 cannot communicate with those 5 PCs in VLAN 10 unless we do what we call inter-VLAN, which we are going to see as we proceed with the lecture. So to begin with, let's jump straight away into Packet Tracer and see how this works. Okay, here we are in Packet Tracer. So we are just going to take a network switch. Let's take this fast Ethernet switch. So if we open the switch and go into the CLI, it's still decompressing. Okay, so here we are in the switch. Now, if we look at the VLANs that are in this switch, let's say show VLAN. This is the command to see the VLAN that is in this switch. Show VLAN. Now, you will see that all the ports of this switch are in VLAN 1, which is the default VLAN or the native VLAN. So you see that this switch naturally have one broadcast domain because all the switches are in one VLAN. So when we now introduce the concept of VLAN, we divide these ports and put them on the different VLANs, thereby creating multiple broadcast domain. So that is why we say it gives the possibility of moving from a single broadcast domain to multiple broadcast domain. If you look here, you also see that there are some other VLANs that are in the switch, but most of these VLANs are unsupported. We are not using them. They are just there. They are web-based. They are on old technologies, and they were just put there for some technical reasons. And I want you also to know that there are two types of VLAN. We have the standard VLAN, and we also have the extended VLAN. So we are going to look into that first. But first of all, let's start by creating a VLAN. Okay, before we create the VLANs, let's connect some PCs into this switch. Let's get some PC into this switch so that we better understand the concept of VLAN. Okay, here we are. Let's all connect them. Okay, so what I'm going to do is that I'm going to give these PCs an IP address in the same subclass. And the reason I want to do that is for you to really understand the issue of communication between different VLANs. Okay, so let's go into our IP and give it a static IP. Let's just start here, 192.168. Let's just use .10.1, and then the subnet mask. So this is the gateway and the DNS server, but for now we do not need the default gateway because we are focusing on layer 2 and we are not getting out of the network. Remember, default gateway are used to when you want to access a different network. Like let's say you are moving from one network to another, you can now use a router, and that router you can then use it maybe like the IP you assign on that router, you can then give it here as your different gateway. DNS server is of no use at this particular point. So we are just going to focus on our IP and VLAN on this particular topic. Okay, we have successfully assigned the various IPs to these PCs. So normally, you know that PCs that are in the same subclass, normally they are supposed to communicate with each other. So let's say if you use this PC, and let's say you ping the last PC, which is this PC with this IP address. If you ping this PC, normally the ping will go without any interruption. So you see that we are receiving a reply from this PC. This is because all of them are in one VLAN, which is the VLAN 1. All of them can communicate to each other because they are on one VLAN, which is a native VLAN, so they can communicate with each other. And again, they are on the same network subclass. The same as if you use this PC to ping this one. Let's take this IP address. So if you use this PC to ping this one, most definitely you will receive a reply. Okay, you see that we are perfectly receiving a reply from all the PCs. So all these PCs can communicate with each other because they are on one VLAN, native VLAN, which is VLAN 1. Now let's go ahead and create different VLANs and assign this PC to those different VLAN. So what we are going to do, we are going to create two VLANs, which is VLAN 10 and a VLAN 20. Okay. So to create the VLAN, you simply just need to enter the command VLAN and you give the VLAN number. Like now, VLAN is created. VLAN 10 is created. Now, the following thing is to give the VLAN name. So let's just say the first set of 3 PCs, we'll put them in the finance. Let's say they're in finance. So that's the name of VLAN 10. And then the second set of PC will create VLAN 10 for them, VLAN 20 for it, and we give the name, let's just say we give the name sales. Okay, voila. So now we have successfully created 2 VLAN. If we go now and check our VLAN table, you will see that these VLANs we have just created have been added. So let's just say show VLAN. So you will now see that 2 new VLANs have been added, which is VLAN 10, and we name it finance, and we have VLAN 20, which we call it sale. And I told you that there are 2 types of VLAN. We have the standard VLAN and we have the extended VLAN. So standard VLANs ranges from the value of 1 to 1005. That means you can create VLANs from 1 to 1005. These fall within the range of standard VLAN. So above 1005, we are now moving to extended VLAN. But most of the company and enterprises do not need the extended VLAN, because the value from 1 to 1005 is enough to cover most company and most enterprises. So most of them, they do not need the extended VLAN. But service provider, internet service provider, that is ISPs, if you are working in an ISP company, an internet service provider company, most definitely you will need more than the standard values of VLAN. That is where extended VLANs come in. Okay, that is where extended VLANs come in, because you need to render services, connect different computers, connect different company, give connection to different, many and thousands of people. And for that reason, you will come to a point where the standard VLANs values or all the numbers will be exhausted, and you will need to move to the extended VLAN. So this is where extended VLANs comes in play. Okay, it's mostly for internet service providers. Okay, and now if you want to see the values or the value range of VLAN, you can say okay, if you said VLAN and you put a question mark, you see that it will give you the range of the VLAN. So you have the standard range, which ranges from 1 to 1005, and then from 1006 to 4094 is the range value of the extended VLAN. And you cannot create VLAN directly the way you create standard VLAN. There are some conditions that must be applied. So if I try to create VLAN 106, you'll see the switch will reply me that VLAN create fail to create VLAN 106, extended VLAN not allowed in current VTP mode. So this means that to create extended VLAN, there are some certain things or some rules that you must follow. First of all, your PC or your switch, must be running VTP version 3, or you have to put the switch in transparent mode. Okay, you have to put it in transparent mode. You have to put the VTP in transparent mode. So only with these 2 conditions can you create extended VLAN. Okay, so let's go ahead and see. Let's try to put the switch in VTP transparent mode, and let's see. So we enter the command VTP mode transparent, and we click enter. And now let's try to create VLAN 106. So you see that we have successfully created the VLAN. We can go ahead and give the name, let's just say HRO. So you see that we have successfully created it. Without those 2 conditions to apply, you cannot create extended VLAN. Okay, that being said, let's go ahead now and try to see how we can assign our ports to the different VLANs. So this one we have here, fast internet 0, 012 to fast internet 03. Okay, so to assign the PCs to the different VLAN, we have to hard code the ports. Yes, we have to hard code the port. That means we have to put it in a switch mode, and then we assign it to the particular VLAN that we want. Okay, so let's say let's go now and try to hard code the port. So we said interface fast Ethernet 0. Now let's use range so that it will save us time. Internet fast range, interface range fast Ethernet 0/1 2 3. Okay, so now we are in this 3 interface, and then we now hard code it. We said to hard code it, we use the command switchport mode. Switchport mode access, and then we tell the switchport to access VLAN 10. You see that immediately the state goes down and then it goes back up, thereby putting these 3 different pieces in VLAN 10. So they are no longer in the native VLAN. Okay, so let's do the same for this other one. We have interface from where? Let me see. So we have fast Ethernet 042 to 06. Okay. So we say interface range. I'm using the short form, but the full spelling is interface range fast Ethernet. You can spell the fast Ethernet if you want, but this is to save you time. The short form is more preferable. Fast Ethernet 0/4 to 6. We enter, then we hard code it. Switch port mode access, and then we said switch port access VLAN 20. You see the state goes down and it's now removing those ports from VLAN 1 and putting them in VLAN 20. Okay, so let's now go and see our VLANs and the changes that we have made. So we say show VLAN. Voila. So if we now look here, we see that we have VLAN 10, which is finance, and we have these 3 ports that are now under VLAN 10. You have fast Ethernet, port 01, port 02, port 03, and we have this one for sale. Okay, we have this one for sale, which is port 4, port 5, port 6. Remember, this other one here is the extended VLAN that we created, but it was just for us to understand the purpose, how extended VLANs are being created. So now let's go on and see something. Now they are in the same network subclass. Let's see if this PC can communicate with this PC. Okay, so we take the IP address of this PC, and then we come here with ping. You see that we are receiving a successful reply from this PC too. Okay, so now let's try to see if we can use this other PC to ping this other PC. Let me put some color drawing to distinguish the various VLANs. So we put here So here we have VLAN 10, and then over here so over here we have VLAN 10 here, and we have VLAN 20 here. Okay, okay, so let's try to see if this PC can ping this other PC successfully. So the first reply says request timeout, second reply says request timeout, and the third reply says request timeout. And the fourth reply says request timeout, which means that this PC cannot communicate with this PC, but they're in the same subclass. In IP addressing, they are all in the same subclass, and we know that IP address in the same subclass can communicate to each other. But why can't this particular one communicate with each other? Is because they are now in different VLAN, and two different VLAN cannot communicate with each other. So this is where we said VLANs also serve as a layer 2 security, because if you have people in one organization but in different departments, and you don't want those in one particular department to communicate with the people in the other department, you can simply put them in different VLANs, so that people pertaining to a particular VLAN can only access resources pertaining to that particular VLAN. So this is where the concept of layer 2 security comes in. Okay, so I guess that is it for the concept of VLAN. What else am I missing, or is there any other thing that we can talk about? Okay, I think that will be it. So even if you use another switch, let's say you are not just using one switch, you are using two switches. Okay, you are using two switches, not just one, and this other switch here is serving some PC. It's serving some PC. Let's just come here and we create VLAN 10. VLAN 10. Name. Finance. Okay, so we have created VLAN 10 here, and let's put those other pieces that we have just created in the finance. Okay, so now we have put these other pieces in. Okay, we haven't given it an IP address yet. Let's still give it an IP address in the same subclass. So let's see if this PC can communicate with this other PC. So you see that this PC can still communicate with this other PC because they are all what? In the same VLAN 10. So once they are in the same VLAN, they can still communicate with each other. The reason I was putting this other second switch is to introduce you to another topic, which is VTP trunking. Because imagine that in an enterprise where you have also several switches and you have to create several VLAN, and you need to walk to each and every switch and create the different VLAN. Let's say you have about 50 different VLANs. You will have to walk up to these various switches in their various locations and create those different VLANs to assign the various ports into it. It will be very strenuous. So this is where something we call VLAN trunking comes into place, whereby you can set one, once you create a VLAN on a particular switch, that VLAN get replicated on all the switches across the network. But we are going to look into all that in a different lecture. So for now, this is the concept of VLAN, and this is how you create VLAN in your switches, and this is how you assign them to your switch port. Okay, thank you for watching. See you in our next lecture.